Okay, so you're welcome once again. My name is Evans. I'm still your mathematics facilitator. This is Mazris TV. You can follow me on YouTube, TikTok. You can also follow me on Facebook. All right. Yes. So, but don't forget to subscribe, like, and share the video so that anytime I post new videos, you get the update. All right. So I will not waste my time. Let's quickly look at this question. So in our previous lesson, we were able to solve the 2025 core mathematics. Okay. Yes. So today we are going to look at the 2026. They just ended Wassce core mathematics for private candidates. All right. Yes. So let's quickly look at how best we can go through these questions. All right. So as I said previously, that once we are done with the various theorems, we are going to go through a series of questions. Okay. We are going to look at how questions are being asked about those theorems and how best we can solve them. All right, so we'll not waste my time. Let's quickly look at our first question. So for this question, we are seeing that in the diagram, G, D, and F are points on a circle. Center A, line CE is a tangent to the circle at D. Angle DGE is 51 degrees and angle FG is 38 degrees. So we are to calculate for the angle of CEJ and also look for the angle of CDJ. Yeah, so let's quickly look at how we are going to identify some properties that we've learned previously in this question. All right. Yeah, so in the first one, we are to look for what's angle CED. So let's first identify that angle in the question. So CED, okay, CED, G rather, yes. So the angle at what E, that is what this question demands. All right, that is what we are looking at. So in this question, how do we get that angle? Now, before we get that angle, let's consider this quadrilateral. So we have that is um, DA, AF, FE, and ED. Yes, so this is the quadrilateral. We have four-sided figure here. And as we all know that to find the sum of interior angles of quadrilateral, we just what add them, and then it's going to give us what 360 degrees. So once we're able to find the various angles in this quadrilateral, then it becomes easy for us to find the angle at E. All right, so let's find the one at F, we find the one at A, and we find the one at D. Okay, yes, so first of all, let's consider this line that is JE. That's a straight line, or we can say that is what is a secant. Because yes, if you extend the point from J, you get a secant. So when we talk of a secant, we are talking about a line that intersects a circle at 2 points. Okay, yes. So if we have that line, then we have EF also as a line. You realize that these two lines, okay, they meet at point F. Okay, and once they meet there, you see that the angles, two angles are formed there. So these two angles are what adjacent angles. For that matter, they are also angles on a straight line. And as you know, properties of angles on a straight line, we are saying that they sum up to what 180 degrees. So we can just add the 30 to the angle at F, the 38 to the angle at F, and just equate 180. Okay, and then we find the angle at F, that is AFE, as what 142 degrees. Yes, so this helps us to get that angle. Okay, so once we know that angle, then we can move on to find the other angles as well. So we are also going to find the angle at E, that is the angle at the center. Okay, so let's identify this shape. Okay, yes, so let's look at which property is that. All right, yes, yes. So for that property, you can recall that if you have this shape inscribed in a circle, okay, yes, so if you have a circle like this, then we label the parts, okay, or the points, okay. Then let's try and turn the circle, okay. Let's make it look nice. All right, let's turn it like this. Okay, so if you have this, remember in this theorem we said that an angle at a center, okay, subtended by two radii is twice the one subtended, okay, by the chord at the circumference, okay. Yes, so if you have um this shape there, then we can talk of what? Radius ED and radius AF, okay. Yes, so once you realize that these two radii, okay, are formed, then the angle formed at the center is twice the one that is formed at the circumference, okay, and for that matter, angle at what? G. So if we know angle G as P, then we can say that the one at A is 2P. That means twice the one at the circumference. Okay. Yeah. So if that property holds, then and we know that angle at J is what? 51 degrees. Then we can conclude that if twice of 51 degrees gives us what? 102 degrees. Yes, very interesting. Yeah. So once we are able to get that angle, then we can just conclude that then the angle at A in the question is what? 102 degrees. Okay. Yeah. So once we have gotten that, then let's move on to the angle at D. Now let's also identify which property we can use to get that angle. Okay, so before we go there, let me advise you, as I've been saying that before you be able to solve circle theorem, you should be able to know all these properties. Okay, and circle theorem is just a combination of what? Both plane geometry 1 and plane geometry 2. So plane geometry 1, we dealt with angles, straight lines, triangles, and all that. And for plane geometry 2, we have added circle, okay, and some properties, okay, or some theorems. So if you're able to study all these theorems, then it becomes easy for you to answer questions. All right, so if that is the case, then let's continue. So we are going to consider this, okay, this theorem. Remember when we were learning our theorems, we said that if you have a circle and have a center, so let's take it as center A, then you have a tangent, okay, you have a tangent, okay, then if a line is drawn from the center to meet or to intersect the point where the tangent line what touches the circle, okay, so that line from the center, as we know, is what? Radius. So the radius of a circle to um or intersect with the tangent line, what property is that and what does it say? Yes, that is what we are talking about. So remember we said that since that radius is perpendicular to the tangent line, then the angle from there is what? 90 degrees. Yes, that is what that property is saying, because if you look at the radius, you realize that the radius is perpendicular to the tangent line. So at the point of tangency, then the angle formed there is what? 90 degrees. If that's the case, then we can conclude that angle D in the question is what? 90 degrees. Okay, so now that we know all these angles, but we don't know the angle at E, we can easily calculate for angle at E. It's just a matter of summing all these angles and equate what? 360, and then we are good to go. So we just do our calculation, okay, and then we find that value there, and that is going to give us yes, that's going to give us what do you call it? Yes, so we are going to get 26 degrees for that angle. For that matter, we can conclude that for question A, our answer is what? 26 degrees. Okay, now let's move on to the B, where we are saying we should find the angle CDG. So let's identify the CDG. Okay, yes, so this is the particular angle we are talking about. Right, let's also identify something here. Which property is that? So if we have this line and this line joined together and this one joined together, you realize that for this shape, GDE is what? It's a triangle. And then if we extend D to C, then there's a line there. There's a property. And when you send your mind back to when we're doing plane geometry 1, I remember these theorems where we say we have what we call the exterior angle theorem, the exterior angle theorem. And what did we say about that? We said that if you have a triangle, okay, if you have a triangle, the the one which is exterior, or the exterior angle, okay, of the triangle is equal to the sum of two opposite interior angles of that triangle. Okay, yes, so if that's the case, then the one which is outside, which is exterior, if you take angle at G and take angle at E, if you sum them, they must be equal to the one at what? D. That is what we are talking about. So if you have forgotten, let me send your mind back. Yeah, so if you have this triangle with these various dimensions, then we are saying that if you want to get the one outside, so the exterior angles are A and B. So if I want to get A, then I will sum two opposite interior angles, that is N and M. They are what? Opposite to A. So N plus M gives me what? A. And the same way, if I want to get B, which is the exterior angle, then the two interior angles which are opposite to B, these are what? N and P. So if I add N and P, I must get B. That is what this property is saying. Okay, so if that is the case, then let's get back to the question. So since we have G at 51 and we have E, angle at E as 26, then we can just add them. Okay, so 51 plus 26, and that is going to give us what? 77 degrees. So it means that our angle for CDJ is what? 77 degrees. Very interesting, right? Yes. So that's it, and that answers everything. So as I've been advising you, that this circle theorem is very, very easy. It's not difficult. All that you need to do is to study all the properties. Okay. Yes, know all these theorems, both plane geometry 1 and plane geometry 2, because most of the questions are combination of plane geometry 2 and plane geometry 1. All right, so if that is the case, let's end here and continue next time. So please, if you have any submission, you can go to the comment section, leave your submission there. If you have any question, you can also ask question. But please don't forget to subscribe to my YouTube channel. This is Wassce TV. My name is Evans. I'm still your mathematics facilitator. So see you next time. We come again with another question. All right, so let's meet once again in the next lesson. All right, bye bye.